Now here we are discussing about another combination, right? Another combination resistance. Right? What happens to the resistance if the bulbs are connected in parallel combination? Parallel combination is what simply you are allowing the current through them individually to the bulbs using same source, right? So here parallel combination from the battery, right? Individual parts connected to a common. Terminals of the bulbs are connected to a common. That common is connected to the battery using the switch. Then what to observe here? What you are required to observe? So here I am observing using the multimeter, right? So what amount of voltage is maintained in the first bulb? Bulb 1, what amount of the voltage is maintained? Bulb 2, what amount of voltage is maintained? Bulb 3, what amount of voltage is allowed? So individually I can verify. V1, V2, V3. I can note down the values also, right? Then compare these values. What you can realize. After switch on, measure the voltage. After switch on only, right? So the gap is filled. Then the voltage is maintained by you using a source here, that is 9 volt or 12 volt or 6 volt, whatever it may be. Okay. That voltage measured through individual bulbs here, noted as V1, V2, V3. Then compare them. So what you can observe here, voltage maintained through individual bulbs are same as the voltage given by your battery. So same potential difference is generated between the terminals of the bulb if they are connected like this. So bulbs are connected in parallel combination, right? Bulbs are connected in parallel combination with the battery. So parallel combination is what? You made individual parts from the battery to any bulb, right? One failed, remaining works. Then you need to measure the current values through individual bulbs, I1, I2, I3. So use ammeter to connect in each branch, So then what you are going to realize. So here you can connect an ammeter, then note down the values as I1, I2, and I3. Then compare. Are they equal or less than or greater than compared with the other? So here you are realizing they are not equal to any value. Then measure the current passing through the circuit, overall circuit. So that current is taken as here I. So measuring the four values, Then try to establish a relation between I1, I2, I3, and I4 currents, right? So here, after connecting and measuring the values, you are observing all the four currents are giving you the different values. So here, when you compare the currents, one is different from the other. Then how you are establishing a relation between these four currents? The overall current and the remaining three currents, right? So it is equal to what? I1 into I2 into I3, or I1 minus I2 minus I3, or I1 plus I2 plus I3, or I1 plus I2 minus I3. Like this, you can follow many combinations, right? So finally you are realizing I1 plus I2 plus I3 will give you current in the overall circuit, throughout the circuit. So this, I got the relation. Then here, converting this I in terms of resistance using what? Ohm's law. So, sorry, right? In terms of Ohm's law. So here V equal to IR. From this, I want I is equals to V by R. So this is the relation. So I1 equal to V1 by R1. I2 is equals to V2 by R2. I3 is equals to V3 by R3. Then substitute them individually here. V by R1, sorry, V by R, V1 by R1, V2 by R2, then V3 by R3. What we know? V1 is equals to, V2 is equals to, V3 is equals to V only. Voltage remain constant. So left side and right side, V gets common, right, and cancelled. Then here what is remaining? 1 by R. So overall resistance here taken as equivalent resistance. So R equivalent is equal to V gets cancelled, 1 by R1, 1 by R2 and 1 by R3. So this I got. This I got. So this is the relation between the resistors and equivalent resistance. So 1 by R EQ equal to 1 by R1 plus 1 by R2 plus 1 by R3. In which combination? Parallel combination. Right? So parallel combination equivalent resistance we will calculate by using this relation. So you have a definition also here. Equivalent resistance in parallel combination, equivalent resistance in series combination. So that too I am writing here. Right? So here it is in series combination. This is in a parallel combination I got. Right? So here all these are making you confused. So I'm removing them. Right. So you have only two formulas. One is in series combination and the other is in parallel combination. So equivalent resistance in series combination. Look at here. Equivalent resistance in series combination is given as what? Plus. Plus means what? Sum. What sum? Sum of individual resistances. Right? Sum of the individual resistances will give you the equivalent resistance in series combination. What about in parallel combination? Equivalent resistance is written denominator, in the denominator. So reciprocal, right? Reciprocal of equivalent resistance in parallel combination is equal to sum of the reciprocals of individual resistance. Right? Sum of the reciprocals of individual resistors. So like this, we can define the equivalent resistance in parallel combination and equivalent resistance in series combination. Are you clear about this one? How I define using the formulas only? Have you got idea? Yes. Right. So everyone got clear idea about these topics, I think. Right. So we'll stop our discussion for today at here. Tomorrow I'll discuss, right, about the calculation formulas in series combination and in a parallel combination, right? In series combination and in a parallel combination. So example problems we are discussing. Okay. So we'll meet tomorrow at same time. Thank you for joining.